app you can find for there's the recording in progress. Um, and there's Lakehead up there, located on the north side of Lake Superior. So yeah, I just wanted to start off with that. And then giving a little background on Lake Superior. I'm sure many people in this call are pretty aware of Lake Superior and the other Great Lakes. So I just want to just briefly touch on it, give the context of the system that I'll be talking about today. So it's the most intact native fish community that we know of in the, or, sorry, that in the Great Lakes based off of the fish assemblages that are still present. It's the largest lake in the world by surface area. This is how it stacks up. It's circled there in the green to a lot of the other Great Lakes of the world. You can see it's only kind of lagging behind the Caspian Sea in both the metrics of maximum depth and surface area. But Caspian Sea has got a little bit of salt in there. So largest freshwater lake in the world by surface area, we can pretty confidently say. Um, as many of you know already, whitefish, cisco, and lake trout are the main commercial targets in this lake, and a major part of the management going on in the lake. And this management relies on acoustic fishery surveys. So this is just kind of a plot of what the fish biomass in Lake Superior has been looking like in recent years. You can see that there's been a bit of a decline since the 1990s, where harvest has actually continued to climb in recent years. So it makes managing this fishery and understanding what's going on really important. And so, as I had mentioned before, and as is the main focus of this, well, coregonines are the main focus of this seminar series, but for me, it's going to be cisco here. Um, so they're open water fish native to Lake Superior, and they're threatened by climate change and commercial fishery pressures, specifically for their roe or their egg fishery. And then in recent years, the recruitment has been really sporadic and very low, with the exception of 2 summers ago, when a lot of this research was taking place. So I'll have that little caveat in there. You can see the little abundance estimate there shot up, which is part of the excitement that I'll be talking about kind of in the second part of my presentation. The other reason we care a lot about cisco is that a lot of the recent extinctions from the Great Lakes are their close relatives. There's also been a lot of extirpations of different forms of cisco in the lower Great Lakes. So this species is definitely one that can be vulnerable to different different fisheries or different anthropogenic stressors. And then, like I said earlier, their management relies quite heavily on ship-based acoustic fishery surveys. So what is a typical fisheries acoustic survey? Basically, you have a transducer that's mounted on the bottom or off the side of a boat. It sends a ping down through the water column, which then encounters a fish's swim bladder, where that then echoes back to the transducer and gives the fish's approximate size and then location in the quadrant beam by pinging off those 4 different split quadrants for a split beam survey, which is what are typically used now. So why do we use these acoustic surveys? Some of the advantages of these surveys are that the surveyed fish survive the sampling, where most net-based surveys, the fish will not make it or be processed for different things. They also provide an accurate density estimate. Net mesh sizes don't come into play. The sound doesn't discriminate how big or how small the fish are. It also allows us for easy sampling over broad spatial areas. You can drive a boat over a long distance fairly quickly and be sending down the pings to count the fish. It also allows for easy sampling near structures. There's no net that's going to get hung up on anything, so we can get closer to things that are a little bit more treacherous to sample with traditional net surveys. However, there are still some disadvantages. The main one being it does not give a species of fish, so it's pinging off their swim bladders, so they often need to be paired with netting surveys if you want to know what species you're dealing with. They also give minimal temporal detail as you're driving over these fish at a fairly high rate. You don't really get to see exactly what's going on for those fish for long periods of time. You're just getting a large area. And then also there has been some work that I've been a part of and others have been looking at in the Great Lakes that fish may be exhibiting some ship avoidance behaviors, that this loud, noisy vessel is coming through. They may try to move either horizontally away or dive down away from the ship. And then there's also the surface exclusion zone, which is built into the physics of the transducer, that there's a near field where the data just aren't good, and can't be really used for understanding the fish. And then we kind of double that to make sure that there's no bad data getting in. And what that can ultimately can lead to is the upper 10 meters being a little bit undersampled. So, based off all these things, how can we maintain the benefits of acoustic surveys while improving upon their biases? So for our group, we decided to deploy a stationary uplooking survey. That's the C Spider up there, which is the stationary acoustic unit, where we'll send it down to the bottom and it'll send pings up at the surface. So you can kind of see in the map or the diagram on the right, that's what the platform would be doing. It's sitting on the bottom, looking up at the surface. So the cone is nice and large in that upper 10 meters, whereas the ship is losing a lot of that 10 meters and looking down and having the widest beam at the bottom. So this hopefully allows us to completely remove ship avoidance bias and most of the surface-based bias. And this also offers a trade-off between spatial breadth and temporal detail. As I was talking about before, the ship can cover a large area. This platform is stationary, but the platform can sit there for long periods of time, and we get to see what the fish are doing just naturally without any kind of impacts from the ship. So I'll talk a little bit more about that in the second part of my talk, and as well as this part where it can track the individual fish speed, direction, and depth of these fish, so we can get a live look of what they're doing. But it still doesn't give the species, which is why pretty much all my surveys have been paired with netting data right now. So the first thing that we were doing here was to uh, do some sampling in Thunder Bay. There's a Cisco survey that already takes place in Thunder Bay with the Ontario MNR, where the Cisco come in at their spawning time in the fall and they go out to survey them and see what the commercial quotas can be set at. So we partnered with them and deployed the Spider out at 3 different locations in fall of 2020, 2021, and 2022. All of these deployments were around 2 to 3 nights, and they were at about 30 meters of depth. And that's how they're spaced over there on the left along the transects. So we wanted to have some direct comparisons of how the ship survey compared to the stationary survey. And then with the standard ship-based survey, they did night set gillnets, where they were able to pull that 99.9% of the fish caught in the gillnets were Cisco. So kind of going forward in the fall survey stuff, we can be fairly confident that the fish that we're looking at are Cisco. So for my data, to make sure that I can keep that thread going, that we're just looking at Cisco, I eliminated any fish that were smaller than adult Cisco, around 155 millimeters, going with some other standard operating procedures that the Minnesota DNR and the Ontario MNR use. And then I also excluded any fish that ended up being larger than 496 millimeters, which were the max netted Cisco length from the surveys over the 3 years that the MNR accomplished. And then these surveys, we split them into 20-minute grid cells and calculated fish per hectare so that we could compare the stationary unit directly to the mobile survey. So this is one of the biggest findings that we had. This is in the upper water column. Overall, across all the locations and the years, the platform picked up about 6.7 times as many fish than the ship in that upper layer. You can kind of see I have the little cartoon there that you will help orient you on what section of the water column I'm talking about. But you can see that every single one of the sites and every single one of the years, there were more fish detected by the platform than the ship in that upper layer. And then when we move to the lower um, part of the, yeah, sorry, I'm just pausing for a second because like the little recording thing is covering my title for me, but this is the lower. So the ship and the Spider were a lot more similar in most years, although in 2021 you can see that the ship picked up significantly more fish than the platform. But even across all of these, when you look at it, the ship only picked picked up about 2 times more fish than the platform in this lower part of the water column, where most of the time these cisco wouldn't be spending the majority of their time. And so it's kind of interesting to see that although there's a little trade-off there, the upper water column benefits ultimately lead to the platform picking up 2 times the amount of the ship. So that's kind of leading into this next one. Um, we saw across the surveys overall, the platform outperformed the ship. And like I said, in that 2 times factor across everything, there's a couple of different ones that there wasn't a huge significant difference between the platform and the ship. But overall, we were seeing more fish with the platform looking up at the surface. So from all of this, we found that Cisco estimates improved using the stationary unit. It also made us more confident in using the unit in other applications, that it was getting estimates that were similar or greater than what the mobile surveys were doing. It seemed to reduce the survey impacts of ship avoidance and the surface exclusion zone in the system. And then for the Cisco density estimates, the upper gain outweighed the lower loss, like I was talking about earlier. Um, and when I converted things over to quota estimates, you can kind of see that plot over there on the right. Um, you can see that the platform was either greater than or equal to the quota estimates that the ship was producing across those years. And the dark bar is the harvest that the M&R reports in Thunder Bay. So you can see there's a little bit of discrepancy there that we want to try to dig into going forward. So some of the main conclusions from this part of my research is that it supports recent uplooking work. We were able to use a uplooking sled with my master's work and found that there were 2.5 times as many fish across all the different surveyed sites with this, or the sled saw an increase of 2.5 times, basically because it's doing a similar thing looking up at the surface. And the platform saw that 2 times more Cisco density, so that there seems to be some agreement between these two service-based uplooking methods. And then these ultimately, we're hoping that these better density estimates mean more informed management decisions and better protection of the Cisco populations. So this kind of leads into part 2 that I alluded to before. So now that we're pretty comfortable with the unit, we wanted to try to get at some of the other big pros that this type of survey has, which is allowing us to look at fish movement patterns more directly. So this is yeah, so for looking at fish movement in Lake Superior, we do already know a few things, or are pretty sure about a few things in the lake. We know that fish in Lake Superior undergo deal vertical migration as well as deal bank migrations. So deal vertical migration is typically in the deep water areas of the lake, where we see our different coregonine species as well as lake trout following this nightly migration that the mysis do. So you can kind of see over on the left column, that's the mysis, and that's where they're found in the water column out at some different sites. And they do this during the peak daytime. They're down at the bottom, and then in the middle of the night, they come up towards the surface. And for most of the fish, with a kind of the exception of cisco in the fall, they follow this up and down movement pattern of or DVM. Also, some work has come out with Owen Gorman looking at some deal bank movements in some of the more nearshore areas of Lake Superior, which a lot of my sites, once I moved out into the main lake during the summer, would be considered kind of nearshore, offshore, right on the cusp of that. But he was able to see that there were about 24% of the fish in that region were making these deal bank movements, whereas the rest of them were mainly DVM. Fish also undergo seasonal migrations to spawn, so they move and congregate in these different areas depending on the time of year. And then we can also look at, or we also know that there's been some energetics modeling that have found spatial differences in fish movement. And this was mainly using fish tissues and trying to estimate activity from there. So what I kind of wanted to answer with this part was, do the direct measures of fish movement confirm and/or add new insights into the deal and regional movement patterns that we've already observed in the literature. So for this part of my research, the study design was to sample a bunch of different locations across Lake Superior. You can kind of see them plotted down there. I had 12 different deployment sites. These ones were 1 to 3 night deployments, just with the nature of getting the ship time to get the platform in, the platform out during the summer of 2021 and 2022. And these were put in waters from 34 to 72 meters. So like I said, kind of near shore to right on the cusp of offshore for Lake Superior. But as you look at the map, you can kind of see these are still relatively near shore compared to the main body of the lake. So when I was looking at these data, I split the fish into 3 size classes. The 30 to 155 millimeter or small size class that we were expecting to be mainly rainbow smelt. The medium size class, which was 155 to 483, which were mainly Cisco. And there's paired netting data. So actually, these are matching up really well with the netting data that we have. So rainbow smelt, Cisco, um, and then any fish that was larger than 483 was put in the large category, which are mainly lake trout, based off of the nets. And then we examined regional and daily fish speed, which in body lengths per second, and relative capture depths of these fish across the different regions to try to understand if there's these regional differences present, and if there are these differences between day and night cycles happening in all these locations. And just to refresh everyone, or I guess not refresh, but explain to everyone what my relative capture depth is, I tried to standardize for where the thermocline was. So if the fish was near the surface or at the surface, it would get a RDD score of 2. If it was at the thermocline, it would get an RDD score of 1. And if it was at the bottom, it would get a RDD score of 0. So jumping right into the results, we saw some definite year variation in the small fish depths uh, in our RDD. So you can kind of clearly see, I'm not sure if everyone can see my mouse or not, but in 2021, the fish were found predominantly at or below the thermocline, except for during the day in a couple of the sites. And then in 2022, it didn't matter if it was the day or the night, the fish were almost only found above the thermocline in the data that we were looking at. But the thing that I was kind of talking about at the beginning was that this 2022 year was a huge year for young of year coregonines. So what we think might be happening is that in 2022, we're seeing this pulse of coregonines that it's kind of pushing everything up towards the surface. Because based on the literature, young year coregonines prefer temperatures, water temperatures that are a bit warmer. So this top layer would be around 16 degrees. Whereas rainbow smelt prefer a little bit colder temperatures, so any of the fish in that lower area would probably be more likely to be rainbow smelt. So that kind of makes sense with the breakdown that we're seeing this huge variation in where the small fish are based off of this huge pulse of young and year coregonines in the lake. And along with this, we did still see some DVM in the western arm area for the small fish. It seemed like there were fish found lower in the water column during the day. Sorry, I didn't talk through that originally on the plot, but all of the white violins are day plots and all of the black ones are night for each location, displaying that relative capture depth or relative detection depth. So we saw expected DVM in those 2 years in those 2 sites. Whereas in most of the other sites, actually, we saw reverse DVM where fish were caught or were detected higher in the water column during the day versus the night, which was a bit surprising, or it had no real difference between day and night. And then for the medium and large fish, we still kind of we didn't see a huge difference in where the Cisco or the medium fish or the large fish were spending their time in the water column. They all kind of seemed to hang out mostly around the thermocline with a little variation there. And then as far as DVM, there wasn't really a lot of significant differences in the deal vertical migration patterns for these fish. A little bit in Nipigon Bay for the large fish, and a little reverse, or sorry, a little reverse in Nipigon Bay, and or sorry, a little sorry, In Nipigon Bay, it was expected DVM, and then in Whitefish Bay for the medium fish, it was a little reverse DVM where the fish were higher during the day and deeper at night. So overall, with the stationary unit, we found some surprising DVM patterns. We only saw direct DVM in a few sites, and this may have actually been due to the few fish that we were able to detect during the day. So that was something that I didn't mention yet, but we looked at the number of fish that we saw, and during the day we only saw about 411 fish. Um, versus at night there were 7,000 small fish detected by the stationary unit um, across the surveys. So this seems like there may be a bit of a novel minority strategy that we're looking at, that the fish that are remaining during the day get up close towards the surface and school up rather than trying to dive down at depths. And this is a little bit supported too, because we're able to get the direction data from what the fish are doing at the different times of day due to the stationary nature. So at sunrise, the small fish seem to mostly be moving towards shore across all the sites. I have the blue arrows there on the map showing the leading direction that the fish were going in that kind of hour around sunrise. And then small fish were moving towards deeper water at sunset. So this kind of makes sense for these deal bank migrations that these fish might be undergoing. Um, and then for large and medium fish, it seemed like they were just moving deeper at both sunrise and sunset. All right, so jumping into the fish activity data, so that's the speed or at which they're moving around in 2021 versus 2022. Again, we see this huge difference. This one we looked at the three sites that I was able to sample both years, so Western Arm, Nipigon Bay, and Whitefish Bay, and we saw that there was this very distinct difference of elevated fish swim speeds in 2022 versus 2021, which again we're kind of attributing to the coregonine boom and the smelt being the predominant small ones in 2021. So smelt have a lot slower swim speeds, slower max swim speeds, and average swim speeds. So it makes a lot more sense that the once the system becomes dominated by young of year coregonines, suddenly all these small fish are moving a lot faster. But we also saw that the medium and large fish overall were moving faster in 2022 compared to 2021. So we then year corrected all the data. Since we were seeing all these impacts of these small fish, we acknowledged that there's a huge difference in year for these fish movement patterns, but we were still interested in seeing what the differences between day and night and regional differences were. So we adjusted for um, the overall speed differences that I showed on the last slide for all of the sites so that we can compare across all the different regions. So there's a lot going on on the left figure, but I'm just going to try to consolidate it and then talk about it a little more in the next couple slides. But basically, what all of that is saying on the left is that the small fish overall moved faster at night. The medium fish didn't really have any change in speed at night versus the day. And then the large fish actually slowed down across all the different sites significantly at night. And then looking at regional differences, which are more the gray bars along there, we found that the fish in Whitefish Bay were slowest across all the different size classes, and this area is associated with the outflow of the lake. So we're thinking maybe that could be a potential reason for these slower movements, that there's not a lot of nutrients pouring in at that site. But these are just hypotheses. We're just observing this and trying to tie it a little bit together. And then the Western Arm and Nipigon Bay, we see a lot faster movement patterns overall across the fish sizes, and which are areas of high inflow. So overall, with the stationary unit, we were able to improve our temporal and deal fish movement understanding. It was able to observe differences in yearly, regional, and daily movement speeds and relative detection depths. It also found some common trends across the sites, that small fish were spending their time were shallowest in the water column, even across years compared to other fish, whereas the medium and large fish hung around mostly at the thermocline. And then it also gave us new insights into what's going on with the young of year coregonines, what's going on maybe at these, and maybe even given us some thought to take at these inflow and outflow regions, and kind of a direction to explore with this observation of more DBM and less DBM. So the major implications for the study could also, for at least from a management perspective, could be that passive nets could overestimate populations in high activity regions. So if the fish are moving around a lot quicker in a certain area of the lake versus the other, but you're using the same type of gillnet survey, you may get a higher estimate from an area of high fish movement speed compared to other ones. So that's definitely something to take into account. There's a lot more nuance to the DVM and DBM in Lake Superior that bears a little bit more looking into. And then I just kind of also wanted to add in here that a longer time series and more sites, as is typical in science, getting more data can often shed more light on what's going on, but it'll definitely help us unpack the complexities of these the new findings by the stationary unit. And hopefully this can also ultimately help us protect our coregonine species in the lake, their intrinsic cultural value, and then also for their commercial and recreational value as well. So thanks everyone for your time, and I'll be taking any questions here. And I also have a couple of other back pocket slides if people have any specific questions about some other things that I might have glossed over too quickly. But thanks everyone for listening.
Thank you, Ryan. And maybe we'll see some of the virtual applause that we can do via this format. And at this point, we do want to open it up to questions. You can ask questions either ideally by flipping on your camera and asking Ryan directly, or you can type it in the chat and, we can ask Ryan that question there. One quick question. So it seems like the first part, it was in Thunder Bay, that was stationary.
Mhm.
You were comparing it. And then the second part, was that also stationary? So you would just leave
Yeah.
the spider there and not, so would that be a passive gear also? Or, I mean, in some ways?
Yeah, so in some ways it's I guess more passive than a mobile survey. But as far as sampling, like it can we can actually calculate the fish movement
Right.
speeds as it goes across, so we know like their speeds and their activity rates from that, um, rather than so yes, we would detect more fish if the fish are moving around more, if that makes sense. But we weren't really looking at density in the second part
Right.
too closely. We were looking at just the overall movement speeds and directions and patterns. We
Um,
did actually look at density as well, which was one of the slides that I had. But like you're saying, the passive might have a little bit of that bias in there. Um, but let me see if I think it's the next one. Yeah. So that was another thing that I like kind of played into the point that I was making in the second part, that we did see big differences in the Cisco densities by the stationary unit. This is for the summer data. In the We saw a lot more fish at night than during the day. Um, which is kind of why I got into like maybe it's more this deal bank movement, because we still are seeing what you would consider DVM, just by looking at density, but by looking at the actual raw movements, we weren't seeing the fish like angling up or moving like upwards. It seemed like they were moving away during the day and the night, but maybe they moved off and then did normal DVM or something like that.
and as you mentioned too, you have the issue just with them as they're in school, like schools, it's probably hard, just like with regular acoustics, to find single targets, right? So that could be another reason that you alluded to, where you getting lower densities during the day if they're schooling.
Yeah, yeah, definitely for the smaller fish. The medium and large fish, you can typically at least parse out the individuals in some cases with this unit, just because it's got the wider beam and you can kind of track it through there. But the small ones definitely look like just kind of a cloud of backscatter. So that can be a little bit difficult to quantify in what we have right now with the tools we have.
So one other question while others are waiting. maybe Ryan, how have managers reacted to? I mean, you showed some big differences there in terms of densities between the shipborne acoustic estimates versus your stationary that gets those higher densities up near the surface. Are there movements afoot, let's say within, I don't know, from any of the assessments to think about, for example, in the next CSMI iteration, when I know that there is a lake-wide acoustic estimate, I'm
Mhm.
guessing both of these different methods will be used, the upward, maybe stationary, and combined with the downward, especially when you get deeper and maybe the cone going upward isn't as broad and sort of in 100 meters of water versus 30 meters of water like you
Mhm.
had in Thunder Bay.
Yeah, I think that as far as management response, the M&R definitely was really interested in what's going on with the stationary unit. They were our partners with a lot of this for a couple of reasons that I didn't get too deeply into, but the surveys for Cisco are done in November and on Lake Superior and at night, which are not the best conditions to have a crew driving around back and forth out in the bay. And so the great thing with the stationary unit is that you can go set it in whenever you want and program it to turn on to collect these data when you need it. So you can go out on the best day of the week when it's flat, calm conditions. You can go out during the day, um, set it in there, and it's pretty quick set and retrieve process. So that would cut down on a lot of expenditures for crew and a lot of long nights for crew. And there's definitely been some interest in like getting an array of these units out in Thunder Bay to try to keep looking at across these different years, are we seeing these more consistent differences? Um, and one of the things I did look at too that I didn't include in this because it was more methodological than coregonine based. But with the stationary unit in Thunder Bay, we had a 3-day deployment that we were able to look at the fish densities across those 3 days, those 3 nights. Um, and each night there were more fish. Whereas the ship went out and did its survey the first night only, so they would have only captured the fish densities from night one. Whereas the spider was able to give us night one, two, three, and you could just see the pulse of the fish coming into spawn. So that's definitely something that people at the MNR at least are excited about maybe using as a tool to better catch these spawning events because you kind of just have to try to go out when the weather works and when the ship time works and everything. So, um, and I know there's a lot of um, work with that Daniel and the sail drone guys have been doing with the acoustic surveys across Lake Superior, trying to incorporate that um, less impacted sampling. I know I've heard from them that with the sail drone, that they're not seeing as much of a difference between the sail drone and the ship down looking surveys. So maybe something that we'll need to kind of dig into is there a um, more aggressive dead zone that we're seeing with the acoustics that we don't actually know that we're seeing? Maybe it's less ship avoidance and more this looking down from the top rather than up from the bottom methodologically that could be causing some impact. So definitely something that everyone's kind of been interested in trying to understand this upper water column a little bit better.
And do you think the spider would work as well if it were in deeper water, say out in the middle of Lake Superior, in terms of at least in the hypolimnion? Would it because its cone would be more narrow, kind of the same thing that you're facing from the ship going down that narrow cone, or you definitely would get great surface coverage still, but would there be more of a bias in deeper waters?
I think to a certain degree, likely that like if you're really interested in fish that are near the bottom, that the stationary unit's not really something that's going to help you understand that population. But I think deploying it deeper is better for the spider overall, just because that cone like has more time to widen and collect more data across the area. So um, you'd still be having a bit of an underestimate in the lowest areas of the lake. But the pairing that with down-looking surveys might be able to um, help you reduce that bias if you're interested in those areas, kind of just throwing that in and trying to understand those differences.
So what is the deepest that you set it in that second year or the second and third years when you did the more of the spatial survey?
I think it was around 75 or 80 meters, but all
Okay.
of the like internal workings of it are rated for it can go to the deepest part of Lake Superior with the
Nice.
pressure and everything. It's just we were limited by rope,
Yeah.
the length of rope that we were able um, to procure to get it in there, and then also we wanted to pair it with the typical surveys and actually what Sail Drone was up to that year as well. So we wanted to stay in those areas if we could.
Yeah, this is fascinating. And Hansi has a question here in the chat, wondering about the flip. I was asking about the maximum depth that you entered. He said, what's the shallowest that really the spider could work well? 10 meters or so, he asks.
Yeah, I mean, I think um, that's a good question. For Lake Superior, I've always been thinking like the goal is to get deeper with the spider. And Thunder Bay is like a fairly, I mean, it has some deep parts, but overall it's 30-ish, 40-ish meters, where it seems like the spider works really well there. I'm sure there is a depth where it would be fairly ineffective, as far as the cone would be very small coming out from it, but you could work around that with different frequencies, different beam angles. If you really had to deploy it in a shallower system, you could get a acoustic unit that would be able to have like a wider cone that in the main lake would be unsustainable. So it would just be so much like widening of the beam. You get a lot of crosstalk. But if you wanted to deploy it in a shallower system, I think that it could be adapted for that. With the equipment that I have on it right now, I think that you'd probably want at least the 10 meters, and even then maybe 15 just to have it give it enough time for that beam to attenuate out. So yeah.
Do you remember how much the spiders cost? What does one spider cost?
Um, it's a little tricky to answer just because it was kind
Yeah.
of pieced together from a few different sources.
Okay.
Mike did give me the quote at one time. Um, and I used to have that on top of mine, but it's like it's a good chunk of change because it's just the acoustics and stuff. I think it was around 20 grand for the whole thing, if I'm remembering correctly, although I should make sure I'm not missing a zero on that.
Okay.
Um,
No, that's okay. That's I'm
but
not
yeah,
great with numbers when people ask me those either on the spot. So.
yeah, for the spider, it was definitely the DTX sub, which is the brain, which is Biosonics, is fairly expensive, and then the transducers are expensive, but they're the ones that we use on the ships down looking anyway. Um, and then the batteries are a bit expensive too. So, and then the frame that I guess is going to just depend on where you get it from. Yeah.
So Hansi's comment, like he like appreciated your answer and that he saw the utility of using this into some shallow areas, as you were alluding to, as they, by having it in 3 days, you could sort of detect that spawning run entering and building within Thunder Bay. And there might even be some shallower areas or even rivers where this might be a useful technology, depending on the depth limitations. So let's see, other questions out there from folks? Oh, Peter, please go ahead. Thanks.
Hey, I was just typing out, but I think it'll be easier for me to say out loud. So when you're calculating or talking about the same minimum maximum depth thing, um, are you thinking about and calculating it to the surface, like surface to bottom depth, or to where those fish might be? I'm just thinking about, in situations where your bottom depth might be a little shallower, but the thermocline is fairly deep, where many of the fish are right below that thermocline. That it might only be 15 meters, but the actual depth of the lake is much deeper. So should you consider that? Like, should we be considering that basically like depth to where we expect the fish are, or depth of the total column?
Yeah, I think that you definitely want to consider where the fish are for sure to maximize the data you're getting back. Um, with the sea spider, with the spider itself, I know that like typically what we would recommend from like the SOPs and everything is to make sure that um, you'll be gathering data within the window that's two times the near field zone, which is that area where like there can't be any data processed by the acoustic unit. Um, and the Spider actually has a pretty the 120 that it had on there had a pretty low near field zone. So it was I think it ended up being about a meter, where that data like within a meter of the surface of the transducer would be considered unusable. So it does give it some flexibility for those shallower systems, but it depends on the questions you're trying to answer, right? Because the data would be good. It's just that will it see fish is like the question, right? So like you can use that data, but how often is the fish going to swim across a cone that's a meter wide or half a meter wide versus like more like 5 or 6 meters wide? So that's where you'd have to kind of play around with the frequencies available and the beam angles available, which I know there are some wider angle beams that can deal with that have been in use in river systems for salmon spawn and more side looking stuff, I think, if I remember correctly. But
Cool, thank you.
Go ahead with
Ryan,
your question. Thanks.
I've got a question.
Oh, hang on. Let's get Ben Leonhardt, and then we'll get you, Dan. I'm
Thank you.
glad you jumped on there, Dan. Thanks. Ben, go ahead. Oh,
Yeah, yeah, that was a pretty cool talk, and I've kind of got two questions that are probably related to each other. When you were, is the spider continually running like all day, or is it on just like at certain points of the day? Um, and I guess if it's on all day, are fish generally moving back and forth, or are they just kind of just hanging out in the water column? Because I'm just wondering if you're getting this, if fish are just hanging out, and you could be measuring or seeing the same fish all day long, and if that could potentially affect your density estimates.
yeah, so the way I have it set up right now is that it is just on like nonstop. You can schedule it to like come on at certain times or have like more truncated sampling, which we are looking into that as well as like seeing how accurate those estimates would be on a more strict sampling schedule. Um, However, like in the spider's view, you can see the fish moving around, and you can tell if there's a fish that's just sitting there, right? Because it just comes in and it would just be a line for an extremely long period of time. But overall, looking across the day, especially at night, fish don't seem to just sit in one spot. And then, I mean, I guess really in the day, they're going by really fast. Like there's just schools zipping by. But at night, they slow down and branch out, but they don't go that slow that they're just sitting there. So for the most part, I would say like 95, 96% of the fish that I see don't stay in the beam longer than 20 minutes, which is part of why we were using that as kind of our cutoff, that
Oh,
there's not really likely a fish that's going to sit there for more than that period of time that I was seeing really in any of the data. I think there might have been one individual that sat there for quite a while in one of the deployments. That I think I removed it just so that it wouldn't like cause that issue. But for the most part, fish seem to be moving fast enough through that they're not. That's part of the built-in bias and maybe the assumption that we're trying to push forward here is that like it's possible that it's the same school of fish, but you do get direction from the fish. So like it doesn't seem like they're just circling on top of it, like you would be able to
mhm,
tell if they were like doing
yeah.
loops, but I wouldn't be able to say if they like swim for, if they're swimming in like some sort of like oval shape, like going past, swimming out, going back, coming around and like doing a loop, like I the spider wouldn't really be able to detect that, but we would hopefully be able to um that we're assuming that they're not necessarily doing these intricate patterns and they're swimming within the bay. and they're more random movement, kind of based on some of the stuff that Dax group has done with the fish behaving and schools behaving like kind of gas particles that they just kind of disperse. But
Uh, so when you were estimating your density estimates, did you take like snapshots through the day and then snapshots through the night and then kind of put those like kind of an average or something to kind of get your estimate done?
yeah. So we did 20-minute blocks where we like took the density from that block and those were our kind of increments to look at. And for the fall stuff, I only looked at night data. I probably should have like
Mhm.
clarified that more because the ship only did night surveys. Whereas in the summer we looked at the day and the night and split it up into those 20-minute blocks.
Awesome, thanks.
Thanks, Ben. Hey, and Yule.
Yeah, I got a couple of questions. There were sites that showed higher densities of small fish in daylight hours in the upper water column. I think you pointed out that was at Nipigon Bay and Whitefish Bay. And I wondered if you had considered how turbidity might influence fish distributions in your results, because I have seen that before occur in turbid systems. You'll see small pelagic fish in the open water during daylight. So I wonder if you could comment on that, and then I'll have another question.
Yeah, I think that for the most part, uh, the deployments that I was able to do, we didn't take like the numerical turbidities other than what the MNR normally does with the ship data. I know that the Kai probably has some information on that from some of the ones that we had it together. But for the Nipigon and Whitefish Bay, we did we did deploy it with a GoPro on the Whitefish Bay deployment and got footage of it going all the way to the bottom. So there seemed to be a bit of clarity there. And then the Nipigon Bay one was at the mouth of the bay rather than deep in the bay. Because we did do a deployment in the deep bay, but I didn't include it in any of this data set because it was mostly looking at whitefish and perch, and not really behaving like a pelagic system. Um, Whereas the mouth of the bay, the nets around that area were picking up mostly cisco and lake trout, like a lot of the other areas of the lake. So turbidity could definitely play a role in those sites as well. Um, so yeah, definitely something to think about as well. It just seemed like based off of the fish community there, it was behaving more like a pelagic site would in those areas. But yeah, that's a good point.
Okay, and this one's probably more along the lines of how someone might review your work when you submit. But one of the things that I saw on the map of Thunder Bay, where it looked like most of the spider deployments were what on the western side of the bay, where it's shallow. You said 30-meter deployment depths there, and the acoustic transects, of course, were running further to the east, and it gets deeper as you head towards the sleeping giant. So there's tends to be lower densities over that part of the bay, where especially where it's really deep. And so when you did your comparison of the ship-based survey and the sea spider and the different layers, were you sort of limiting the ship to maybe the western side of the lake, or were you comparing it to the samples that were collected over the bay, the entirety of the bay?
So we're doing it over the entire transects. I did in the first like bit of looking at the data, looked at just segments closest to the spider.
Mm,
So I definitely could do that. But we wanted to kind of give it a true comparison to like treating it as if it was its own full survey and then treating the ship as if it's its own full survey.
mm,
Um, so that's a good point. We definitely, when I looked at the data, I cut off from the ship data any water that was below, I think it was the 35-meter mark, um, just to keep it, or I think it was 40 meters, just so that any fish that the ship detected below that, that the spider wouldn't have really had a chance of detecting, weren't even really in the comparison, if that
mm,
makes sense.
mm.
Um, And that was kind of standard with what the Minnesota DNR does with their acoustic surveys, even their down-looking surveys. They cut off below that 40-meter line in a lot of areas in the near shore for Cisco. So,
And one last question, comment, more of a comment, I think, because this is also interesting to me. I think that we always sort of knew that the ship-based sounding was providing us conservative estimates of, because our inability to sample the near surface waters. And I can send you a paper that I did that included Thunder Bay data, where we had much higher densities of Cisco from mid-water trawling in that upper water column compared to the acoustic. So I don't think it's a new necessarily problem we've identified, but what's interesting is now we have a means to know how conservative the ship-based estimates really are. And when we've thought about management, at least in my feeble mind to this point, we were always telling the managers that the estimates were conservative, and therefore when they were setting quotas based on those estimates, those quotas would in fact be conservative also, because we knew that there were some unknown portion of the populations that weren't not getting sampled. So now suddenly we have a situation where, well, managers and fishers eventually will come to realize that the acoustic estimates have, this issue. And so it raises all kinds of questions about what could transpire between quota setting and the agreements that are struck between the fishers and the agency setting those quotas. So I don't think you have to answer that. It's just it does complicate the world a little bit, Ryan.
yeah, no, I agree. And I meant to say that in the first question that brought up managers that Bo had, but I kind of deviated a different direction. But something also to keep in mind is that this is like brand new data, right? This is one survey, or kind of starting to build off of some work recently of uplooking stuff. So we're trying to like understand what's going on. And like Dan said, like we know that we're trying to be conservative with the downlooking estimates. And just because the spider sees more fish doesn't mean that we should pop these quotas way up. Like we're understanding that the trends in the lake are the trends, right? We've been seeing these declines in the populations in certain areas, or kind of like wide in the recruitment until this year, I guess, or until 2022. And I don't think that just because there's more fish there than that the spider's able to see, that means that these trends need to be disregarded or reversed. Like I think it makes it so that maybe like Dan was kind of alluding to, and what we were hoping based off of the conservative estimates, that there are more fish there to kind of do these remediation efforts to preserve the population than we maybe were estimating, if that makes sense.
Yeah, and now we have, like, what, best available science always evolves. So this is could be a pivotal moment where our understanding really changes, and our ability to, with new tools to survey those populations better, is becoming realized. So I'm not afraid of the future because of it, but it does have ramifications, I think, for sure.
So Dan, if I can sort of ask you a question with Ryan. So you've been using the sail drone, which is a way of avoiding potential ship noise, scaring fish away. And it seems to me you have had an upward looking, but is that ship based? Is that right? Is that what you've been doing, upward looking on the? I don't remember that.
No, a good question, Bo.
Yeah.
The sail drone that Ryan talked about is it has many of the same issues that a ship has, in that it's, I think, some distance where the transducer is below the keel. It's quite deep, actually. I think it's 2 meters, and if you account for the near field where the sound waves aren't fully formed, Ryan talked about that issue. I think it's going to undersample at least the top 5 meters of the water column. So not much of an improvement over the ships, except it's quieter. But the work that we've done comparing ships to sail drones through overtake experiments, where we would compare data collected with those two platforms directly as we overtook the sail drones with the vessels, doesn't show much of a ship effect. They tend to have very similar estimates across I think 5 vessels we tested on Lake Superior. The other platform that we're also evaluating through the USGS high-tech effort is the, well, it's an AUV, and it has both up-looking and down-looking capabilities, and it's flown at depth. And we are working on data that were collected in 2022 and 2023 at present. And that does show promise for being able to sample that very difficult place to sample in the top 5 meters or so of the water column. And I think I can say that preliminary work indicates that that the densities that up-looking mobile AUV obtained in that layer are higher with that platform compared to the ships. But those data are still being analyzed, processed, carefully poured over so that we ensure that they're the very best they can be before we roll them out. So that's where I'll stop.
That's helpful to know more about these battery of new technologies that can get us to less biased estimates, perhaps.
Mm-hmm.
We're really excited about the AUV because you know, the current version of it can travel up to 500 kilometers without having to be brought back to have its battery charged. So that's, you know, 10 nights of deployment or thereabouts, which is, you know, the ranges are increasing with what you can get between a battery charge. Yeah.
I also found the cost estimates from like a quote from putting together the spider. So there was a bit of a like there's like a deal with it or whatever. So I think Mike got like 20% off or whatever it was. So it ended up being like 130,000-ish. But that depends on like how many transducers you want and what kind of I guess deal in the package you can get too. So it was, yeah, maybe I did underestimate it when I was saying it earlier.
That's all right. Yeah.
Um,
Thanks for looking that up.
Mhm.
All right. Any final questions out there for Ryan? Okay. Well, Ryan, thanks again for taking your Friday afternoon and sharing your really interesting results with the broader community. And we hope to see everyone back early March to hear more about whitefish and Lake Constance. Until then, have a great weekend, everybody.
Thanks for having me.